All right, everybody. If you didn't get the chance to do so, I've placed all the materials for this meetup tonight in this OneDrive link. You can find it here on the meetup advertisement. If you go there, you will find in a OneDrive folder the document that I'll be covering. That's kind of my guide, walkthrough, additional information about creating RevitAddins. You'll also find a text file that has a path to my GitHub repository for this code, as well as the code itself. If you don't want to get it through GitHub, it's there. And the images that are also being used in this document for the examples. I've also included the Revit lookup with all its original code already built for Revit 2020. This is from Jeremy Tamick. It is an exceptional tool that allows you to look at stuff in the Revit database by calling methods and properties that you'd normally see in the Revit API and seeing what those return back to you. So I'll be covering that later and showing you kind of how that's useful. So tonight with the presentation, it's not going to be linear. Just like coding, it's not, coding's not linear. You always find yourself jumping back and forth. What I will do is I will show you what this add-in that I've put together as an example, what it does. I'll also show you how to kind of get started making your own add-in and the components that are critical to making a Revit add-in, and I'll also be walking you through my code so you understand what I was doing whenever I put it together in the examples. So to start off with, the add-in that that I developed for this presentation, it's very simple. Wanted to keep it, as simple as possible, very straightforward, so you understand how to make something basic and go from there. The add-in creates its own tab on the Revit window, also creates itself a button, and creates a small UI that pops up. What this tool will do is it'll invoke a selection of elements. It'll also provide you feedback about the elements you just selected, and it will crop your view to those elements based off their bounding boxes. So I'll show you that code, how that was developed, and how all these components came together. And I literally wrote the guide that I included from the perspective of as I was developing it, so you can see the step-by-step process. And I'll be working with Revit 2020 for this example. So first thing first is if you want to get that code, again, I said that you can get it from the OneDrive folder, or you can get it from GitHub. If you're not familiar with GitHub, GitHub is a great way to store code so that you can make multiple versions of it. You can do what's called branching, where you make essentially an option of it. It's great for restoring and going back or seeing what you've changed. You can also share your code with other people and collaborate together. So I highly recommend getting into GitHub if you haven't learned about it yet. When you sign up for GitHub, you'll have your space for repositories. You can also go to other people's repositories and get their code. So here I have this URL to my GitHub repository, which is the same exact code information that was in that OneDrive folder. If you go to clone or download, you can get this URL and you can open up in your GitHub desktop or directly in Visual Studio. So this URL is the same as the one that's in that text file in the OneDrive. So if I select that, I can then go into GitHub, file, clone a repository, and I can pull down a local copy of that, that code. And you'll see it's going to go into my C drive, GitHub, and RoMBIS. So give that a moment. It'll come in. And it's pulling from the master branch because I don't have any additional branches, so I don't have any variations of this code branching off. If I say show and explore, there's that code. Same as over here. You will notice that it is, you get additional files for that's related to GitHub. And also these packages I have not yet included in this. I'll show you how to do that as well. So give me one moment. So I'll be working tonight in Visual Studio. The one I have is the Professional Edition. I recommend that you go out and get the Community Edition, which is free if you don't have a professional license through your employer. But yeah, it's completely free. And it has most of the same stuff as a Professional Edition. Professional Edition has some stuff that's more suited towards a professional developer. Additional things to make it easier. So let me expand this real quick. So in Visual Studio, one of the most important parts is it's a Solution Explorer. The Solution Explorer allows you to look through a project solution, which contains several project files, class files, and everything else that makes your code for the add-in. When you first load it, you'll notice under references, I have a couple of yellow triangles for the Revit API and Revit API UI libraries. You'll probably have to go up here to the solution, right click on it, and go to Restore NuGet Packages. And what that'll do is it will restore those library DLLs that I'll be using for this code. So give it a moment. And sometimes it takes a little while to actually recognize that those are there. There we go. Now it should be loaded in. Oh, sorry. There we go. No more yellow triangles. The other way you can add those references, these are installed with Revit. You go to Add Reference, and then under, if you browse for them, go to your project files, or program files, Autodesk, and then your Revit version. And if you scroll down to Revit, you'll find that there's a Revit API UI DLL and Revit API DLL. Those are dynamically linked libraries, which is essentially just code that has been compiled so that you can reference the code that's in it in another program, which is what we'll be doing later on. So that's just a heads up for if you've got the code up and running and you want to take it and follow along. Those are some basic things that you'll have to do ahead of time. One last thing, under properties, if you go under debug, you'll have to specify your Revit executable path if you want to test this out live with Revit. So under program files, Autodesk, Revit 2020, and just specify the Revit exe. That one's actually for Revit 20, sorry, I currently have 2019 set. So let me go do it for 2020. Because I also did this example project so that it will build for both 2019 and 2020. And I'll show you how you can do multiple builds in one go. All right, so those are the basics to get this going with the code that I've already created. Those are things that you will have to do on your own end to get this set up. Unfortunately, it's not something that I can easily integrate in there to be ready to go for you whenever you try running this code. Um, so some other things that may be helpful in your Revit development will be the Revit SDK. Honestly, I only find it to be useful for looking at the examples and also for looking at the official documentation. Again, one second. Yeah, in the Revit examples, you'll find that there is a sample called modeless form external event. That is actually how I got started learning how to use the Revit API and developing my own add-ins. It's an excellent one for showing how to do what's called external applications and using external commands, which I'll be covering. And again, Revit lookup, very important to have. Basically what it does is, for example, I have this chair selected. Go into your add-ins, Revit lookup after it's installed, and say, snoop current selection, because I want to look at that chair specifically. What it will do is it will show you the properties and methods of the API and what they give you back in return when they're called. So if you wonder about things like in the Revit API, I'm going to RevitAPIdocs.com for this, which has all the Revit API information online, so you can easily browse it. I'm looking currently under the document class, which is, of course, a Revit document. If I was to go to my Revit lookup and say, look at my active view and the document that's a part of, go back over here, you'll see that, one second, the properties here in the API documentation correspond to the properties here in Revit lookup, and you can see what calling each of those will return. And you can start going down farther into the database and seeing what individual calls will provide you with. So as you get into your add-in development, this is extremely helpful so that you know what you'll be getting back whenever you try to grab something from the API. Alrighty. In the documentation that I've provided, I've covered some of the basics of programming languages that are relevant to your RevitAddin creation. RevitAddins primarily focus on C# and VB.NET. I'm not going to be able to teach you both of those right now, so that'll be something that you'll have to learn on your own. But if you've learned anything about Python, learning C# is definitely within your capabilities if you can learn Python. But VB.NET, really don't bother with it because it's kind of outdated. Most of the stuff you'll be using will be C#. So yeah, in this document, I'm also covering things about coding, terminology, things that you may not be as familiar with if you've not done much development. But I've included it here so that as I talk about things like interfaces, you know what I'm trying to convey with that. So for example, an interface is a class that is intended to be implemented in another class, and that class inherits the methods that it specifies. And you'll see a couple of those, actually 3 of those in the example. But anyways, just a bunch of stuff about coding there. I do want to cover, before I begin showing more code, what an external application is versus an external command. These are 2 things that are very important to RevitAddin development. External applications are, as it says, they're applications, but they are being launched from Revit. External commands are the commands that an external application launches to interact with Revit. So you can have an external application, for example, the UI of your add-in, but it interacts with Revit's database through external commands. If you develop an add-in that is simply an external command, that's essentially making a macro. And those will show up under the add-ins tab and external tools. So you can see there's one here for Navisworks and Navisworks Switchback. Those are external commands. So again, external applications use external commands to interact with the Revit database. All right. So this first section of the documentation that I wrote out for you guys, jumping in with completed code, is what I covered earlier about how to restore your NuGet packages, how to load in your references, and how to reset the path for the debugger. So I am going to get into how to start this from scratch. All right, so when you launch Visual Studio, what you want to do is you want to create yourself a new project. And for this, we need to specify that we're going to be using .NET Framework. Hold on, it's being a little bit slow. Sorry. So .NET Framework is a variation of .NET. There's also .NET Core. Unfortunately, Revit only uses .NET Framework, where .NET Core is cross-platform compatible. So .NET Framework is limited to Windows, which is one of the limitations of Revit. So you want to make sure to specify that you're using .NET Framework. We're going to be using C# for this. And this one is going to be, you can do a Windows Forms app, which is an older version of how to make UIs in Windows, or you can do WPF, which stands for Windows Presentation Foundation. That is what I will be covering in the documentation. I know some people prefer Windows Forms because it's older, more mature, and it seems more straightforward, but I prefer the flexibility and the appearance of WPF. Plus it is more current and it ties in better with the Revit UI. So select your WPF app for .NET Framework using C#. We'll give this here a name. So I'm naming this RoMBIS test. So the project name and solution name default to being the same. They don't have to be. But you know, it just makes it easier to keep track of what's what. And then under framework, you can change this later, so don't worry if you pick the wrong one. You need to pick the version that corresponds to the Revit version that you'll be building for. Now, of course, if you're making multiple installers, you know, with one code, then you can also specify to load in different versions of .NET Framework, which I'll show you how to do later at the end. But for example, Revit 2019, Revit 2020, those use .NET Framework 4.7. Revit 2021 will be using 4.8. And then 2018, I believe, is 4.6. So I'm going to be picking for this one 4.7.2. You can pick, as long as you stay within the sub number, you're fine. So for example, 4.7, it was what Revit started off with, but you can use 4.7.2. And these .NET frameworks, they're generally installed with Revit. So you shouldn't have to worry about installing them separately. But if you do need to, I've included the links to .NET framework installers at the beginning of the documentation under this section for things to install, download. So you'll see that it started up a project. Over here on the side, I have a toolbox with various controls that I can use to create my user interface. Down here, underneath the design portion, the live design portion, I have the raw code that actually generates the UI here. Over here to the side, I have my solution explorer. So at the very top is the solution. Underneath that is my C# project. And it has properties, my references, and then a couple project files associated to the app, and then it generates this here main window XAML file, which stands for Extensible Application Markup Language, which is a variation of XML. And there is a C# code that goes behind that is used to manipulate things inside the UI. So you can create code on the back end to manipulate the appearance of the UI on the front end. So, and any of these files that end with .cs, that stands for C# or C hashtag. All right, so that covers this beginning portion of the documentation where I go through the process of starting a new project, selecting my .NET framework, showing kind of the general UI interface. If you are missing some of these windows off to the side, or these palettes like Solution Explorer, Properties, you can get to those by going to the View settings. And they're all listed under here. So, for example, there's Solution Explorer, Team Explorer, if you're doing this in a team environment. There's also some other useful windows, such as, where is it? Document Outline. Document Outline is nice because as you start building your UI, what it will do is it will actually list out all the components of your UI and how they're, and it'll also show you like the hierarchy of what components are nested inside of each other. Close that. So going back to the adding the references. References are needed to bring in parts of code that you want to use in your own code. So for example, in this case, we want to bring in the Revit API and the Revit API UI code. So if I go to references, I can say add reference, and then I can browse for those, go to my C drive, program files, Autodesk, and then bring in the ones that I want. So in this case, it would be under Revit 2020, go to Revit, Revit API, and Revit API UI. I can bring them in that way. Make sure you got the little checkboxes beside them checked, and say OK. And there it brings those in. You can tell what version of Revit you're working in based off of those DLLs, those references. But down here in the properties, you'll see that it says 20.0.0.0. And it also provides you information about where those are coming from. Now, let's say I don't want to use my own references because somebody else may be working on my code and they need access to those because if I don't include it in my folders of code and hand that off to them, then they're not going to have the same DLLs that I've been using for my code. So instead of going about it that way, you can remove those and instead use NuGet packages. So one way to do that is you can go to your Solution Explorer and say Manage NuGet Packages, or go under Tools and go to the NuGet Package Manager. Now what NuGet packages are is they are published packages of libraries of code which are compiled to DLLs. So in this case, there's thousands of NuGet packages out there. If I was to search for Revit 2020, you'll see that these are the ones that other people have published that you can consume and use in your own code. So for this example, I will be using Autodesk Revit SDK, and I will install it into my project. Some of these NuGet packages have multiple versions, so you can see that this one here has some for 2019, 2018, 17, and all the way back to 2014. So I'll just say install, and this will go install the Revit API for Revit 2020.1. I'll say I'll accept. You'll see that it's going to throw in the references here on the side. So I got Revit API, ISC, macros. There's my API UI and UI macros. All right, so it's giving me a few warnings down here. The reason why is because I have not specified that I'm using a 64-bit processor. So one thing I want to do for this is if I go under my properties for the project, let's see, set my target platform to be x64. And then also, while we're here, make sure I'm not forgetting anything else. Nope. All right, so that was that about the NuGet packages. I wish I would go away. Sorry, I'm battling with this bar at the top from Zoom. Under your project properties for your code, you can define the assembly name, which is going to be the DLL that gets produced at the end, which should reflect the name of your add-in or your company or whatever, so that it's identifiable to know what add-in that's serving. Default namespace. So what namespaces are is they are the overarching name for a collection of classes of code. So it's a way to organize things above the level of class. Let's say here you can also set your .NET framework. If you pick the wrong one, you can do it here. One thing we do want to do with this RevitAddin is instead of saying it's going to be a Windows application, it's going to be a class library, because we're not actually going to be launching it on its own. Instead, we're going to be using Revit to launch it. You can also set information about your assembly. So if you want to include your company in here, copyright, and set the version of it. So if it's like 1.2, 1.23, whatever, you can put it in there. I'll be covering stuff about build later on, as well as build events. And again, to set your debug so that whenever we build this and we say start, we can specify that we want it to launch Revit. So we can test this out live with Revit. So if I go under my program files, Autodesk, Revit 2020, scroll down to Revit.exe and use that. All right. So there in the documentation is where you can set your external program to launch when you're debugging. So one of the things I want to draw attention to is now that we have set this to be a class library, there are a couple files we don't need anymore, and we actually need to get rid of. We need to get rid of the app.config and app.xaml or XAML. So you can just go ahead and delete those out because we are not going to be utilizing those. If you don't get rid of those and you set it as a class library, this initialize component will show up as an error. So that's why we have to get rid of that. I do want to draw your attention to something. So what I'm going to do is I'm going to split my window vertically so you can see the C# code and the XAML code side by side. One thing to note that is if you change the name of your namespace for your code, you'll also need to change it manually in your XAML code down here at the bottom. So it says for class RoMBIS underscore test main window. What that is my namespace followed by the class for this window. So again, if you change RoMBIS, if I was to change RoMBIS underscore test, I need to go over here and manually change that. Same thing with my XML NS local, where it says CLR namespace is RoMBIS test, that would also have to be changed. Likewise, if I change the name of my class of my window for this UI, say I call it pop-up window, I'd also have to change it over here so that it knows that my XAML code relates to this location in my C# code. Otherwise, you'll get errors saying that I can't find it as a reference. So that is something to be aware of when you're developing your own add-in. There's where I've taken a show to get rid of those two app files because we're not going to need those. The first thing we're going to do, since we got this set up and ready to start adding my components for the RevitAddin, is I'm going to add a class file. So if I right click on my project and go to add and say new item, or I could say new class, I'm going to specify that this is a C# code class library. Yep, so there's class, and this one I am going to name EX application. And this will stand for the external application interface class that I have to implement so that Revit will know from the beginning to load in my add-in as an external application. So one of the things I need to do to begin integrating my Revit code or RevitAddin, Revit API code into this is I need to specify that I will be using classes from it. So go up here, say using Autodesk.Revit. And one of the most common ones you'll be using will be DB for database. There's also UI and application services. So I'll specify that. And this external application class will need to implement the methods from the iExternal application class of the Revit API, which again is that's how Revit will know to take a load in this class that I'm making as an external application. So to implement an interface, you need to specify your class name, in this case, EX application, followed by a colon, and then the class name that you're wanting to interface with. So in this case, it'll be iExternal application. Oh, sorry. Oh, that's going to actually come from UI. My mistake. Using autodesk.revit.ui, if I can spell that correctly. There we go. Because it's trying to only give me iExternal DB application, which is not what we're needing. There we go, iExternal application. And thanks to the auto-correcting features, it knows what I'm trying to type. And you'll see here that it is a interface. It's coming from Autodesk Revit UI iExternal application. And basically, it's an interface that supports the addition of external applications to Revit. All right. So why is it giving me that red squiggly underneath it? That is because I have not implemented the methods that it requires. So if I hover over it, it'll tell me that EX application does not implement interface member iExternal application on startup, which is the method. And on startup takes in a UI controlled application object. I'm not going to get into the weeds of that right now, but as you read through the API documentation, stuff will start making more sense because you probably have not even heard of a UI controlled application before. But whenever you make your own RevitAddin, you definitely will. And also it requires implementing the onShutdown method. That also takes in a UI controlled application. So what we can do is we can start off by declaring those methods. So we'll say public, and we'll say on startup. It has to have the same exact name as the one that iExternal application is looking for. And it will take in the UI controlled application, and I will name this variable UI control app. Now you notice I also have a squiggly line underneath my on startup. So the reason why is it must have a return type. Now, if I was to look through the API documentation, one way to do that is if you select your iExternal application and click on it, it will show you the actual class and the methods that are stored within the DLL that you're referencing them from. And you can see that it is requiring a return of a result. So if I go back here and say this is a public method, it is going to return a result. The method name is onStartup, and the onStartup method takes in a UI controlled application. And I just gave it a variable name of UI controlled app. So this needs to return a result. And what we can do is we can say return result.succeeded. Result is actually enumerable, meaning that there are values associated with it that you can, by typing result dot, then it gives me a value I can return back. And also, I still need to implement public result on shutdown. That's a UI control application. I can also call this one UI control app. And that also needs to return a result. Now, not every time will you specify that something returns result dot succeeded. There will be cases where if something fails to work in your code, you'll return a result dot failed. And that's just so it informs Revit that, hey, I tried to implement this add-in or try to execute this command and it did not work out. All right. So going through the documentation that I wrote here, you'll see that I have taken my UI control application variable that I've supplied, and I am assigning it to another variable, which is my internal static UI control application variable. The reason why I'm doing that is this UI control app is actually an object that Revit provides my method with. I don't actually specify what this UI control app is. When Revit tries to run my method for on startup, it will provide that to the method. And I want to capture that for use later on. So what you'll do in this case is you want to declare something that is a static variable. So I'll say that use an internal static UI control application. And this one I'll start off with a underscore. And once Revit calls on startup, I want to capture that UI control app that it gives me and assign it to the one that I'll be storing for later. Now you'll notice that I have specified something that is public and something that is internal. Public means that it will be viewable to all code, even outside of your DLL that you compile. Internal means that only the code inside your DLL can see it. You also see the things that are marked as private. Private means that that portion of the code can only be viewed within the class or immediate objects that it's being referenced from. So if you know that you're going to have something that doesn't need to be used anywhere else in your code, or you don't want to mistakenly use it somewhere else in your code, you can mark it as private. All right, so thus far I have got my iExternal application implemented. I'm collecting my UI controlled application object that Revit will supply my on startup method. And I've also implemented my on shutdown. So that is the very basic bare bones of what you need to start writing your RevitAddin and its iExternal application implementation. The other side of that is creating the iExternal command implementation. So what I'm going to do is I will go ahead and create another class file. And this time, instead of going to new item, let's go say class. This one I will call EX command. And again, I will have to specify up here at the top that I will be using Autodesk.revit.db, using Autodesk.revit.ui. And I will go ahead and specify one more that I know that I will be using, using Autodesk.revit.attributes. All right. So in this case, as I alluded to, we'll be implementing iExternal command for this one. So it's the same process as with iExternal application. I have my class name, I put a colon after it, and I say iExternal command. All right, so again, what do I not specify here that it requires? It requires implementing execute as one of the methods. And execute will take in external command data. It will use a reference string and also take in a element set. So we'll say public execute and external command data. And I'm just going to let IntelliSense provide me with my variable names just to make this simple. Ref string and then element set. Element set. All right. So what does this need to return? Well, let's go back up here to this information. You'll see that also requires returning a result. So we'll go back here. And we'll say that this will return result dot succeeded. So by default, we're going to say that this is going to work properly. Probably not. The first time you try to make your add-in. So what we're going to do is we're going to use what's called a try catch clause. This is similar to try except with Python. Basically, we're going to say try to do this. If you have an exception or you have an error, catch it and proceed with doing the following steps. So that will prevent your application from hard crashing if something within the try catch is handled properly. So we're going to say try, blah, blah, blah. In this case, we'll assume that we're going to fill this in later. If whatever happens here in the try doesn't work, we're going to catch it. And it'll give you an exception. So we're going to say exception ex. Here's where we're going to use part of the Revit API. We're going to say, I want to inform the user that what that exception is. So we're going to say task dialog dot show. Task dialog are those dialog windows that pop up saying that, hey, you didn't select something or whatever in Revit. And we're going to give it a title. And we're going to report back in the main body of it. Well, it says here main instruction. If you're looking at what popped up in the hover, ex.message. So it's just going to take the message from the exception and display that. So it may not make sense to the person who gets it, but it's better than nothing. Plus, you can look at it later as the developer and resolve it that way. So because we hit the catch, we're going to say that did not work. So we're going to return result dot, sorry, I did not capitalize, got ahead of it, failed. So bad day, that didn't work. One other thing we need to do, and this is where I specified the using Autodesk Revit.attributes. We do need to specify a couple attributes for our external command. And again, our external command is just what the external application will use to actually interact with the Revit database. Actually, do your add-in stuff. So under your namespace and above the class, we're going to add some attributes. So we're going to say transaction, and then we're going to specify transaction mode dot manual. What this means is we're saying that for any transaction with the database, we want to manually do that. We don't want it to go ahead and do it automatically. That's very important. And then also regeneration. We don't want it to regenerate the document automatically and update whenever it doesn't need to. So we're going to say regeneration. It's regeneration option dot manual. So you do need to specify those two attributes ahead of your iExternal command implementation class. Just as with the iExternal application, there is something that Revit's going to provide us in our execute class, or sorry, execute method that we want to keep for later, and that's going to be the UI application. So what we'll do is up here above execute, we'll say internal static UI application. We don't have to specify what it is right now. other than we do have to give it a name. I'll just use that one. So what we're going to do is whenever it starts up, we're going to get this from our external command data. So take my UI application, and I'm going to set that equal to external command data dot application. So that's just one thing that you'll want to capture pretty much in all of your Revit add-ins whenever you call your execute from external command, because that gets referenced later on. Next thing is I'm going to be creating a tab and also a ribbon of buttons for my application or my add-in. So we're going to go back now to the EX application file. So my EX application and EX command are the bare bones, what you need to start off your add-in. I'll go ahead and close this out. Actually, I'm going to leave this other window open just for a moment while I pull up the documentation, so that's not like always overlapping. Actually, I'll just throw that off over there. Close that. Sorry, I need to collect some screen real estate here. So going back to the EX application file, you'll find in my code that I've implemented a new method called create ribbon buttons, and I will be calling that on startup of Revit. That's basically what this means for EX application is whenever it calls on startup, it will take and do those commands in your add-in EX application from the get-go. Then on shutdown is, of course, whenever Revit shuts down, he'll perform those commands. So when Revit starts up, we want it to go ahead and create those buttons for our add-in. So I'm going to create one method called private returns nothing, so it's void. Create ribbon buttons. And then I will call it up here in my on startup. So I can say this dot create ribbon buttons. This means that I'm working inside my EX application class. So that's like a alias for it. So I don't have to type that out every time, as long as I'm still within my EX application class. So I am going to show you completed code for this, so I don't take up the entire time of this typing out everything. So in the code that I've completed, which has all the notes on everything here, you'll see that in my create ribbons or create ribbon buttons method, I am first creating an image source for icons. And that's something I want to bring up is that for creating your icons for your Revit add-in, you'll need to load those in under your resources. So the way you do that is under your properties, go to resources, and you can add a resource from an existing file. This can be a text file, it can be a PDF or whatever. In this case, for this Revit add-in and the documentation I'm showing on the left side, I'm loading in a PNG of the RoMBIS icon or logo. Something to note here is Revit add-ins work best with images that are 96 dpi. That is not 96 by 96 pixels. That's the resolution of the image. So you may have to play around with Photoshop or GIMP, which is a free photo editor, and use that to change your DPI. however, want to have 32 by 32 or 16 by 16 pixel images for our icons. So whenever you load in a resource and say add existing file, you'll bring it in by navigating to it. It'll pop up in right here. If you double click on that and go into your properties for that, you'll see that you got the width and height. You can set those to 32 by 32 pixels, do a file, save as, and save it out as a large icon for your add-in. After that, you'll take and do set this to 16 by 16 pixels, do save as, a small icon. That'll generate two new files for you. And then you'll have to go back into your properties and then load those back in as resources. So that's what I've done here. I started off with a high resolution image. I did the process of double clicking it on here, changing it to 32 by 32 pixels, saving it out as RoMBIS underscore large, RoMBIS underscore small for the 16 by 16, and brought them back in as my resources. So the way I will be using those is back here in the create ribbons. I will be taking those from the properties and the resources directory and specifying the name of those files. I will pass these into a method called icon source. It's just the one that's just my name for it. It is a private method that supplies back a system.windows.media.image source. It takes in a bitmap or just any image essentially. So that's where up here I'm saying, I'm going to call that method. I'm going to supply it my large icon. And what it will end up doing is it will read that icon, that image into a memory stream. That's simply that it reads into memory. And what it'll then do is it will then take that information in the memory stream, it'll begin reading it, and it will put it into a bitmap image source. It'll return an image source. So that's how I end up with this here image source, icon large, icon small. So again, that's my 32 by 32 and my 16 by 16 pixel images. I will then use my UI control app, which I collected from the on startup back here, and I specified as internal static UI control application object. I will call that, and that will allow me to call a method called create ribbon tab. And this is part of the Revit API, in case you get lost on where that's coming from. So create ribbon tab, if I select that, you'll find it here under UI control application. You'll see that it takes in a string for the tab name. So that is where I specify the tab for the ribbon panel, or sorry, for the ribbon. So in this case, it's going to be RoMBIS. Now, something I will tell you later on is if you don't want it to be part of or if you don't want it to have its own tab in your ribbon, you don't have to create this object. You can actually ignore this line right here. It'll put your add-in onto the add-in tab instead. What you do need to do is you do need to create a new button for your add-in. It is a push button data object. So I'm going to say that my variable of push button data is equal to a new push button data object. It has a name of my RevitAddin. This does not get displayed, so you don't have to worry about what that one is. Its text is going to be run add-in. The assembly name tells the button where to go to find the command to launch. In this case, I've made that simple by using what's called reflection. So the code will read back where it's coming from and know what assembly it's being generated from. In this case, the assembly is the DLL that gets generated from a RevitAddin. And then whenever that button is clicked, it will know that it needs to go through my RevitAddin example namespace and go to my class that implements external command, which is my ex command class. Something to note here is you may see that here in my in calling this, in creating a new push button data, I'm specifying these properties with a name followed by a colon. That's another way to pass parameters into a method in a very organized method or organized manner, so that you know, or somebody who reads your code later on knows what those parameters are being assigned to. You don't have to type in name colon. You could just take and type in here your string, comma, next string, so forth. So next is, once I got my push button data, I need to create a ribbon panel to host it in. So you'll notice in Revit, you get these groupings of buttons. So this right here for format converter, that is a panel, and these are your push button data objects. So I'll create myself a ribbon panel for Revit, and I will take and give it a tab name of RoMBIS and a panel name of example in this case. So how those relate to each other is the panel name is this under here in the bottom of the panel. Let's see, your text is actually what goes underneath your icon. So if I was to exclude the tab name, as I was saying earlier, if I exclude that tab name, then my add-in will go underneath the add-in tab. If I specify a tab name, then I need to ensure that I've at least created that ribbon tab. So if you don't create your ribbon tab and then you specify a tab name that does not exist, then you're going to get an error. Finally, you take that ribbon panel and you add your push button to it. So that's how you assign your button to that panel. All right, so that code itself will generate your tab, the panel, the button, icon, and it'll tell that button to go to your ex command class to begin performing operations on Revit. There is another core component of making add-ins, and that is the add-in manifest. You'll probably notice that, I'll show you here. So, I haven't built it yet, so it's not going to show up yet. Let me go to, yeah, here we go. So using Revit lookup as an example. There is a Revit lookup.dll, that's the compiled code for the add-in, and there's a Revit lookup.addin, which is the manifest. Revit reads your manifest to know where to go to actually like load in everything and ensure that you don't have duplicate add-ins. So what the RevitAddin manifest is it's basically a text file or XML file. And what you do is you go up here, say add, you say add a new item. In this case, you'll look for text, basic text, specify your text file. And down here, you would take and say your Revit add-in's name. So in this case, it is Revit add-in example. And you give it the extension of .addin. So when you do that, which I've already done, you end up with an XML file. There are some key components that you need in here. You need to specify that your add-ins type is going to be an application because we're using an external application. The name of your add-in, the assembly that you'll be generating, which has to correspond to your properties assembly name right here. And then specify the full class name that implements an external application. In this case, that is the namespace of RevitAddin example dot ex application. That's the class. You also need to specify a client ID, and this is a GUID, a global unique identifier. The easiest way to generate these is to go online to GUIDgenerator.com and specify that it creates you a GUID with hyphens. Your vendor ID has to be unique, and it is essentially an ID for your company or or whatever business you're running, to specify that, hey, this came from that company. What Autodesk recommends is you take your domain, so for example, RoMBIS.org, and you reverse it to make it unique. Vendor description, that is basically your company name. So that's all there is to the add-in manifest. It needs to go where your DLL goes, which I'll show you later. So there's the documentation covering all that and how to generate it. One thing to note that is you'd always want this here to copy to the output directory along with your DLL every time you build your code. So if you go into properties for your add-in manifest, you'll have an option here, say copy to output directory, and say copy always. That way you don't have to manually copy it over. So this is pretty much ready to go to, this would be pretty much ready to go to build. As you see, I've jumped from the starting from scratch to the completed code because there's simply too much to type in at some point. So for the sake of expediency, I'm going to be working from the completed code for now. When it comes time to build, one of the ways to make it easier for yourself is go under your properties and go to build events. This uses command line code or scripting to specify that after it's successfully built your code into the DLL, you can tell it to then copy it over to a location to then run it. So for example, with this, if I say, so if exist, if program data Autodesk RevitAddin 2019 contains my RevitAddin example.dll, go ahead and delete it because I need to get rid of it so that I can write a new one. And then copy over to it from my output directory from building my code. Copy over my RevitAddin example.dll over to that add-ins folder. Do the same thing for my Revit add-in manifest so that whenever this builds, it'll automatically copy my DLL and my add-in into my program file or program data, Autodesk, Revit add-ins 2020 or 2019. So that makes it so that whenever I do run the debugger, it's already there. Revit knows where to look for it and loads it in. Otherwise, you'll have to manually copy it out of your build folder and put it in there yourself. And in that case, if you really want to do that, you could go under, let's see, RoMBIS example. Whenever you build, it'll go under the bin folder, and it'll be inside the folder in your path for for whatever you specify in the build. So for example, my output path down here is bin/x64/Revit2020. I would go there to grab my DLL and add-in and then copy it over into my add-ins folder for Revit. So that's the manual way. It's not fun. So it's better to have that the build events post-build command line in there. All right. So going back into the documentation for this add-in. So assume that we got this to where it will build, it will then add the tab, the icon, the buttons, and so forth. The only thing we don't have is a UI that's actually functional. So what you'll want to do is go to your main window.xaml.cs, which is under your main window.xaml, or you can right click on main window.xaml and say view code. You'll see here in main window, I have modified it so that it will take in a UI application object. So what I will then do is under EX application, sorry, not EX application, EX command. Give me a moment. So under EX command, this is what runs whenever I click that button on the ribbon. I will tell it to try to see if my main window is null. I haven't generated one yet. If I have generated one, I will bring it to view. Otherwise, I will create a new main window object, and I will supply it the UI application object that I collected from the beginning that's being supplied from the external command data. And then I'll tell it to show my main window. What this does is it prevents having multiple UI windows pop up at the same time, so that you don't have cross data issues with having more than one window open at once. To do this, it also requires implementing some other code in your main window. So whenever main window is generated, main window is actually a constructor. What that means is it's a special kind of method that shares the same name as the class, and it'll generate a class instance object. So it's derived from the main window class, but has its own data, its own properties, and its own unique object. So whenever main window is hit, it will initialize the component. Here, setting the UI application object to the object to store for later use. And then I'm making myself a static main window object that will be assigned this new instance of main window. That may get complicated, but later on I can call my main window class and then say main window dot underscore main window, and it will allow me to retrieve that UI I had just generated, or be able to interact with that UI. You'll notice that I also have some other methods in here. These are for events. So whenever my main window closes, I want to clear out that object that I stored of the main window so that I can create a new one, and I don't take and pull in the old data. So one way to add events to your UI is, this moment, if you select your window in the design environment here and go under properties, give this a moment. One of the downsides to DWPF is that it does run a little bit slower because it tries to update its interface and all that stuff, so it takes a little bit longer for it to kick off again. It just kind of forgets it's supposed to be doing stuff. So let's Give this a moment. All right. So since I have that selected, there's this little lightning bolt symbol up here in the corner for properties. If I double click in any of these fields over here, these are events, and it'll create a new method so that I can do operations whenever those events occur. So for example, I'll create one for closed. So when the window is closed, it will take and clear out that object of main window that I had stored. You can also do things for closing so that as the window is closing, you can save data, save states, whatever, and it'll get that out of the way and do that before it finishes closing. So again, all you have to do is just double click in there and it'll take and create a method for you. So if I go back into the code here, you'll see that when the window closes, I want to clear out that main window object, and that way I have something fresh. So when it comes to things like buttons, so for example, select button. Same thing, if I want to add an event so that when somebody clicks on it, you can go over here to events, say select button click, and then you'll tell it what you want to do with Revit. So in this example, what I am going to do is whenever somebody clicks that button, I will invoke from the Revit API the pick elements by rectangle. And that's going to give me a list of elements that somebody has selected. Now, somebody could cancel that command and the list of selected elements may be empty or null. So I'm handling that with an if condition here. So if those selected elements are null, or sorry, if not null, then I want to take those items that they collected and display them in my UI. And in that case, what I'm using is what's called a list view. This white box right here is a list view. And it has an item source, which can be bound to things like lists, dictionaries, things like that. So what I'm saying in my code here is when somebody selects those elements, go to my list view and bind my selected elements to that. Something to note here, though, is I'm using something called LINQ, Language Integrated Query. I believe is what it stands for. Essentially what it's doing is instead of going through for loops to get the data I want from each of those elements, I'm saying cast all the objects in that list to an element. And from each of those elements, I want you to select the ID and convert it to a string. But at the same time, I want to collect the category and name and also the name of the type. And then I can take all the information from each one and then push that out to a new list. Instead of using a bunch of for loops saying, hey, for each of these elements and this, collect this. For each of these elements, collect this. You can do it all at once with LINQ. So LINQ is highly valuable and something that I recommend learning whenever you're learning C#. I want to collect all those elements and take and have them for use later on so that whenever it comes time to actually crop my view, I can recall those. So what I've done is I've created a static object for crop elements, which is just a list collecting elements. I'm assigning my selected elements to that. And once somebody's selected all the elements that they want and they finish operation, I want to give the person some feedback that, hey, this is good to go. Now you can crop the view. In that case, what I've done is from my main window object, the instance of my main window, I'm taking the crop button and I'm assigning the background a color, which I've defined up here, which in this case is a translucent green color. So let's say they invoke the selection, but they didn't select anything. Then I want the background color of that crop button to be red instead. So if they perform the selection, get everything, this turns green, otherwise it turns red. And you can see that code implemented in the documentation through here as well. Let's see, so that's part of the code for interacting with the UI of the add-in. We need to do some other things. So Revit is single-threaded. So now that we have the list of elements that we want to crop to, we want to manipulate the Revit database, we have to tell the Revit thread that, hold on, we need to insert a request to make changes to the database. So I've created a file called request.cs, and I have request IDs in here. This comes from that example from the Revit samples about making a modeless dialog. So if you want to see more of how to do that, that sample on the Revit SDK will help you with that. But basically what I'm doing is I'm setting a name for each of the commands I want to run to an integer. So as you add more tools, you'll just add more names down here and set them to an integer value. And then I got a class called request, and that actually takes my request to interact with Revit and makes it so it's more thread safe, so that it's okay for me. Revit is like, okay, wait, I'll let you do the things that you want to do to the database, and then I'll pick up from there. I really don't want to go into it. It is very technical. So you can reuse this code for all this code here, and it should work for what you want to do. I also need to implement the request handler, and that comes from the Revit API. So again, I'm using the iExternal event handler, which is an interface. It requires you implementing the method called getName and execute. GetName really does not provide much functionality other than you have to use it and you have to supply it as returning a string. Under execute, it takes in your UI application, and here I'm using what's called a switch case. Makes it real easy so that if I provide a case of that's equal to request ID dot crop view to elements, it'll perform my operation that I want to do on the Revit database. If there's an exception, throw the error. And finally, let me show you something else. Where did I implement that? Okay, so whenever I'm trying to interact with a Revit database, I don't want somebody to be interacting with the UI of the add-in. So whenever somebody clicks to crop their view, the main window will be set to not be enabled. It'll be disabled. So whenever I'm finally done running my request to interact with the Revit database, I'll need to remember to tell the main window to become enabled again. Down here is where I make that, where I take and disable it, so that when somebody makes a request, the handler will make that request with the ID of the command I want to specify or run. It will raise an external event, and then my main window will become disabled. Whenever it's done performing that task, it will try to do the request. It will try to run crop view to elements to perform operations. And regardless of if it's successful, it will always go down here to the finally section, and it will take and re-enable my UI. So just something to be aware of when you're developing an add-in. You do want to ensure that your user is not making changes or trying to run something on the UI whenever Revit's busy. All right. The documentation I wrote for you better explains how these things are interconnected with the request and request handler. It's very technical, so I really don't want to get into that, but just know that if you want to expand upon this, go into the request.cs and add more tools to the request ID. And basically, you'd add more tools based off of whenever you want to make a command interact with your Revit database. So you could have crop view to elements, crop view to room, or whatever, place elevation where clicked. Each one of those would have something underneath this request ID and be assigned to an integer. And then go over here to the execute in request handler and create a case for each one of those. And then underneath that case, specify what command you'll be launching. All right, some more stuff about the UI, which we don't really have time for. This is the completed code for the interface and covers what I was trying to accomplish there. Oh, one other thing is something to be aware of whenever you're making an add-in for other people is they may not know instinctually how that command is supposed to be done. Sorry, looks like there's something in the chat. All right, we got some people dropping out. Anyways, so somebody may not realize that your add-in should only run in a plan view or elevation view. Something you can do is under the EX command, when somebody clicks on your button, and it'll take and run this execute method. And from that, you can then determine if you're in a plan view or elevation view. So this add-in is designed to only work in a plan view. So you can check for what your active view is, what its view type is, and then get from that string, see if it contains plan. If it doesn't contain plan, show them a notice saying, hey, this add-in only works in your plan view, and then return result.canceled because we're canceling that command. So that's something that's good to implement to make sure that somebody doesn't try running that in an elevation view and it just doesn't work or it crashes. Going back to that actual command that I wanted to do. So under request handler, crop view to elements, perform operations, that's actually been defined in another class file. I like to keep my actual commands for the tools separate from the EX command, EX application, and the UI. So it's easier to manage. But you can put them all in the same file, essentially, if you really wanted to. So I have a class called crop view to elements, a method called perform operations. So whenever I'm making my request to Revit, it's going to try to run this perform operations method. So from the get-go, I am creating an object for my Revit document. This is good practice to do because you're always going to have to call your document. Pretty much 99.9% of the cases. I'm getting my current view from my Revit document. And from that, I am taking those crop elements, or those elements that I selected earlier and saved to crop elements in my main window. Again, this is where the static members, the static properties become important because whenever somebody says, select, it returns those selected elements. They get assigned to crop elements, and they get stored as a static property of main window. So for main window, I'm getting those elements. And again, I'm using link. So I'm casting those two elements. And for each one, I am getting the bounding box of that element. And I am getting the maximum point and the X value. And then from all those, I'm getting the maximum value of the maximum coordinate, X coordinate for those bounding boxes. And I've done that for the X, Y, Z, for the max and min. Excuse me. So yeah, again, link is your friend, as I say right here. Link is very valuable. So instead of using a bunch of loops, I'm just doing it all in one line, and it's very efficient. Then to actually interact with the Revit database itself. If you recall from stuff with Python, you do need to use things called transactions. So I'm using a using statement here. You don't have to say using and then declare your transaction and then put it in brackets. This is just another way to keep it clean. It's a way to another way to use C# to keep your code clean. So what I'm saying is I'll be using a transaction that's working on my current document, and the transaction's going to be called crop elevation. This is what shows up in your undo and redo buttons. This is the name. I have to tell my transaction to start, and then I will use a try catch because I wanted to try to get my maximum, I wanted to try to create a new point using my maximum X, Y, and Z values, and a minimum point using my maximum or my minimum X, Y, and Z points. Create a new bounding box, and then crop my current view to that bounding box by getting the crop box of my current view and setting it equal to my new bounding box. And then I will commit that transaction. Now, if any of this fails, I want to go down here to the catch. I want to throw my exception into a message, and then I want to roll back my transaction so that I don't have a transaction that's still open. However, by encapsulating all this stuff inside of the using clause, my transaction will be automatically disposed of whenever it's done running. So that's very nice about the using clause is whatever is defined up here inside your parentheses, it will take and dispose of that object whenever it's done running. So that's in a nutshell of how you create the external application, external command, how to set up your user interface, how to use requests, and how to then make a request with the command that you're actually wanting your button of your add-in to do. And then one last thing I want to cover while we have time is you'll undoubtedly at some point want to do multiple builds. This is where it's a little bit tricky, to be honest. What you need to do is you need to set up configurations for your build. Under the configuration manager, you can see I've specified builds right here for 2019 and 2020. I've also defined, so this is the solution configuration. This is the project configuration. I've made other project configurations here too. I do recommend that you do not use spaces in your project configuration, and I'll tell you why later. What you'll end up doing is after you create those, you'll go to your properties, and you'll see that now my configuration, my active configuration for this project is Revit 2020. I have a compilation symbol called Revit 2020 up here. A catch here, and that's basically so that I can look for that in my whenever I go to compile. The catch though is you cannot just use integer numbers. You have to have some text in there. So that's why this one's for 2020 instead of just 2020. Whenever I go to build with my build events, it'll say if configuration name equals Revit 2019, in this case, or down here, if equals configuration 2020, copy my DLL and my add-in manifest to the correct folder. And if it's 2019, do the same thing, please use this 2019 folder instead. It also helps with specifying which DLLs to add as references, or even what .NET to use. To do that, you unload your project and go to unload project, and then right-click on it and say edit. And normally, you will not have this block that starts this choose block. It'll just be property group, your item group, and then under here will be listed all your references that you've got loaded into your project. So what you need to do is in between your property group and your item group, you need to insert this choose. And what it'll say is when your constants contains, for example, 2019, 2020, you could be contains debug, contains developer, whatever. It will go through and it will add the references that you specify by name and by path. So this is where I can pull in more than multiple DLLs based off a condition of which one I'm building. So here I'm specifying if my constants contain 2019, pull in my Revit API.dll and Revit API UI.dll from these 2019 folders. Otherwise, pull them in from my 2020 folders if my constants contains 2020. Also, within this when condition, you can specify which .NET framework to use. So in this case, they both use 4.7.2, but for example, if this was Revit 2021, I'd say version 4.8. It's also a good place to get rid of references that you may not need. So for example, this NuGet package has brought in some other references that I don't necessarily need. I can wipe those out too. One of the key things is you don't want to have one of the DLLs that you're saying bring in under a condition down here after the choose block, because it will automatically go, okay, yeah, let's say for example, I am wanting to use Revit 2019. So I'm trying to pull in my DLLs for 2019. It'll do that. And then once it gets past this choose block, it'll then pull in whatever I have down here, which may be for 2020. So you want to make sure that you don't have it in both locations. So just something to watch out for. So whenever you're done with that, you can save this, then reload your project, say yes. And then, let me pin my properties here. You'll see that under my references, Revit API is version 20. If I switch over to 2019, give it a moment, click off, click back, and you'll see it's version 19. So this is how you do multiple builds. Now, I said the compilation symbols are also important because you'll find that some versions of the Revit API are not supported in future versions or versions that come after. And so you'll find that something has become depreciated. What you can do in that case is you can use hashtag if Revit 2020, and I'm sorry, this is not the right one. Let me pull this open. So instead, say if, sorry, hashtag if Revit 2020, close it up with a end And if I could say, I can specify something that will only be for Revit 2020. And you can see I have Revit 2019 right now selected. So that is grayed out, so it's no longer going to compile using that code. But if I say if Revit 2019, off with the end if, you can see that that is still active. So that's how you can do multiple builds. And address if you have to do code one way for an older version versus code for a newer version. It's also useful if you want to run something for strictly debug purposes. Alrighty. So I think that's all I can get in for tonight. I'm sorry I got rushed. But there's a lot to cover, and hopefully the documentation will help make sense of some of that stuff as well. At the very end, I've also included links for learning stuff about Visual Studio, C#. W3 Schools is amazing for learning how to code. Stuff about the Revit API through the Revit API docs, the official documentation, and also stuff about learning WPF, Windows Presentation Foundation, for making your UIs. And with that, I will stop recording.